Okay, so we're machining this, and I thought I'd show you guys something. I like to try to turn things into positive when I can. So, it looks like we made a mistake and we're having to redo our control arms. But what we're actually doing is we're inspecting the quality of our welds. Hey guys, welcome back. So, another day, another dollar. We are going to get this camber fixed. So we set the car back down. We kind of made no assumptions. We set it down, we rolled it back and forth. We did get slightly different numbers than yesterday, but they're pretty close. And I really checked it, so I think we're right. And here's what we ended up with. So at the back, both sides are at 4.875, so they're equal. This side has minus 1.8. This side's at minus 136. Now this one shows less negative camber. This is the one that we shortened more. And I remember when we did this, I was like, huh, that's weird that they're different. But they were. I was doing something, something was jacked up with the car. But anyway, now it shows that, okay, actually something was wrong with the car. So now that we got the car level and everything, we now know what to do. So we're going to go do some math and figure out how much to mod the control arms and get on with that. I will say one thing. So this level thing we're using, one question you might have when you're trying to do this is, is your sensor correct? So let me tell you what I did with that. So first, I tried putting it on the floor, and I wanted to see if the floor was level. But it's kind of hard to say because the concrete's bumpy. So I have this level. This is a Swanson. Watch me drop it while I'm holding it. But anyway, this is a pretty good level. It's made out of metal. And I trust this. I've used this before. It seems to be a good level. So I put this on the ground, and it shows the floor is pretty much dead level. And I set it up on a table as well, and I had to shim this table's not level, so I put like some paper here and tried to shim it. And I got the level to where the bubble was dead absolutely perfect. And then I put the digital thing on top of the bubble level, and they agreed. And I even tried doing it both ways, where I slightly put the bubble level to the left or slightly to the right, and the angle finder picks that up. So it does seem that the angle finder it's right, or at least it agrees with this other thing that I believe is right. And it shows the floor is dead level, which, they float these out. It's kind of hard for it to not be level. So it all looks good. I think I can trust our measuring equipment. We got the car, 3 of the corners are at 4.875. This corner, I wrote that it's at 5, but I went back and checked. It's at like 4.9375 or something. I mean, it's within about a 1/16 of an inch of the other 3. There's no way that's going to change the camber in the back very much. Right now, the back of the car is slightly, well, it's just this one's at 5. This one's at 4.875. If we end up keeping the back at 4.875, then I'm going to drop the front to probably at least a 1/4 inch below that. So maybe, 4.5 or a little over, something like that. So we'll see. But I wanted the car as low as possible, so if we can pull this off, great. If we end up going back up a tiny bit, we will gain camber. It'll get more positive. So the adjusters are in the middle right now. This is basically where I want to run the car, so we're going to set it up right here. Okay, so we're getting ready to do our control arms. We marked out on the paper, like on the ground, how we were going to do it. But then I kept wanting to try to machine them. Basically, it's just hard to do this by hand and get it right. And we did it last time, but anyway, we decided to see that, basically we said, look, let's just try to put it in the machine and prove that there's no way to do it. And then I can quit thinking about it and just do it by hand. Well, for better or worse, I actually did find a halfway sort of way to clamp it. So, we're going to either do it this way or break this end middle. But we're going to give it a shot. So this will just be manual machining and just kind of walk back and forth. So we got to remove, we want to remove 0.21, so we're going to add 60 thou, so we have a gap for when we weld. So that's a total of 0.27. Now this is a 1/4 inch end mill, so all we got to do is basically make that's 0.25, and then come back and cut another 20 thou off. So we're going to give that a shot. I don't think this is going to work. I mean, I hope it works, but I'm not very optimistic. But let's see what happens. feel like we need to go slower. Okay, so we're machining this, and I thought I'd show you guys something. I like to try to turn things into positive when I can. So it looks like we made a mistake and we're having to redo our control arms, but what we're actually doing is we're inspecting the quality of our welds. So check this out. Since we're slicing into it with a mill, you get a nice clean picture of how the weld turned out. You can see the top of the weld and the back side. And this is mostly what we were hoping for. There's a big fillet on the like here's the outside of the weld, it looks pretty, but you can see there's a nice fillet on the inside too. That back one gives a perfect view of, there's a nice curve where it blends into the base metal, which is what we were trying to do. So, and there's no porosity. I've been machining this, I get to see it every time it makes a cut, and I haven't seen any porosity. Here's the other one. Let's see, there we go. There's that. Sorry, focus is a little goofy, but there you go. So, kind of cool. Kind of neat to see. Thought I'd show you guys that. Thought that was not something you do very often, get to cut into your own welds like that. Okay, so there's how it looks after running it through the mill. So we got our, cut most of the way. We still got that bottom piece, but we can use the marks from this to line the bandsaw up. And that's what we're about to do. We're going to clamp this down and bandsaw these off and see how it looks. Okay, I thought I'd show you this. Just another welding section. Probably just me bragging. But look at that. We just cut into the weld and it's solid. No porosity, no inclusions. Just looks like a solid piece of metal. Pretty awesome. Okay, so we just completed round 2 of redoing all this. So we just cleaned everything. And it's pretty damn clean. We got, pretty much all the rust and oxidation off of 99% of it. The only real spot you can't get to is inside the crack right there, where they put the two together. But everything else, it's pretty damn clean. And this helps with welding, and that's what y'all saw earlier in those pictures or video or whatever. When we machined the old welds, you could see there was just a nice bead on both sides, no porosity. And that's how you get that. You got to have everything clean so that way the metal can actually stick. Because when you're TIG welding, you don't have, like with a MIG welder, if you use flux core or if you're using like a stick welder, they have flux, and the flux actually does the cleaning for you. And that's one of the great things about those processes. But with TIG welding, you don't have that. You pretty much have to, it's got to be clean on its own right. So we got it. These are pretty good. We're gonna knock off for the night. We were hoping to get this done, but we just ran out of time. But we made good progress. We ended up machining both of these. They're all cleaned, prepped, and at this point we just got I've got a quote-unquote fixture. It's just tape on the floor, but we'll lay this up tomorrow, mark where where they go, and then tack weld them and then fully weld them out. So till then, y'all take it easy. Hey guys, welcome back. Well, we did a bunch of work and didn't film any of it, but we redid the control arms for the second time. Well, I filmed the machining stuff, but anyway, putting it all together and welding it, we basically did the same process as last time. We used tape on the floor, we kind of laid them out, but this time we actually used a square so that we could get all our lines lined up perfectly, and did a little bit better job on that end. And tacked it up and then brought it up here on the table, which I don't have a welding table yet, but brought them up here and welded them out. Went pretty good. The welds are probably stronger than last time, but there's a few areas that don't look as good, but I was trying to put a fillet on the edges to kind of strengthen them so they wouldn't crack. But anyway, we got this put back on. And it still isn't perfect, but this should be okay. So this corner, we were previously at 1.36. We should be at 0, but we only got it to 0.5, and that's a pretty big difference. I'm not sure. I think I said in the last video, as long as we were within 0.5, we'd be okay. So, LOL. But I'm not sure why we came up short. I'm gonna go back and check the math, because I don't think the manufacturing was wrong, because they both turned up short. This one's not as bad. We were at 1.8 and we ended up at 0.36. So both of them came up short, but we're still pretty close. And we got the adjusters in the middle, and they got about a degree of range, so shouldn't be an issue. It could just be this is, my guess is that if you rolled the car back and forth again, it would end up in a slightly different spot. That's probably the real source of this error. But anyway, this still took longer than it should have. Seems to be a theme on this car. But we're getting there, and I'm liking the way it looks. And I wish there was some better light so you can see. It looks pretty awesome. Big fat tires. They're mostly straight up and down now. Like I said, you know, the camber's still slightly off, but we're going to adjust that in a little bit. Get that dialed in just right. But I think we're done screwing with those camber adjusters. I think so. So that's nice. A lot of work trying to get these control arms fixed. But hey, got that done. So we're going to adjust the camber, try to get it close to 0. And then we're going to go on to modifying the sheet metal. Hey guys, welcome back. Well, we just got the camber adjusted using the factory adjusters, and we now have both tires have positive camber instead of negative, and they're both between, one of them's at like 0.05 and this one's at 0.1. So basically just barely went past the 0 mark, and it's looking nice. And this is what we were going for. So we can officially say the camber is fixed, and that's what it looks like. It looks awesome. The lighting under the car doesn't really show it. I don't know, maybe it'll show up better on the screen, but it doesn't look like it shows up good. But anyway, tires are looking great. So we're past that. You know, we got to deal with the sheet metal above the tire. I guess that's the inner wheel well. We're going to start on that.